Next, of course, is Dr. Ting, who assures us he's ready to go. Ting, you want to unmute? Well, Ting is getting ready to go. I wanted to say that he posted a link on the meetup page for his stuff, so I recommend that to you.
Ting, you are muted.
Oh, am I okay?
Now you are.
Okay, good. All right. Okay, let me. So the first thing I want to show you is jeforth 6.13. And the source code is about 20K bytes. And it defines 213 words. And out of these 200 some words, only 109 system words. And if you just keep these system words, the source code is only 18 kilobytes. And to compare it with the original 8086 eforth 1.01, its source code was 47 kilobytes, and it defines 232 system words. So this system is much simpler than the original eforth model. And as Einstein said, things should be as simple as possible, but not simpler. And I think jeforth is at this not simpler state. And I would like to call it irreducible complexity. And this is where we can reduce forth to its bare minimum. So JavaScript is very interesting. And this is the first project I did with JavaScript. So I'm pretty new to this thing. But I have the impression that the JavaScript is really just a C with very flexible objects. And these objects can be anything. For example, here is a list of variables I defined in jeforth. So we have the familiar IP and WP and W variables. These are just pointers. And the stack, the data stack is an object. Return stack is an object. Terminal input buffer is an object with some pointers. And the idioms, these are just the strings that the parser parsed out, is an object. And the most interesting thing is that the whole dictionary, which I called words, is an object. And this object contains all the words which are objects. So I need to make it clearer in my terminology. Words are a word which is used in too many contexts. So here I would define words as objects, which has name field, which has code field, and which has data field. And a dictionary is an array of all objects, all word objects. And tokens are the index of word objects in the dictionary. And so I want to specifically use this term, idioms, which means character strings in a source file, which gets parsed out. And idioms may be words, numbers, or strings. So here is in the jeforth, a word object have 5 fields. And the name field, the code field, which I called xt, and the parameter field for the token list, and qf, that's the data field, which is next to the pf, right? And then there is an immediate field, which has a flag, which indicating whether this word is an immediate word or not. So the word will have at least two fields, the name field and the code field. And it has optional, 3 other optional fields. So the defining words in this system, we have colon, we all know about and love it. And we have constant, we have variable, and we have also array, which can be created by create. So these are the system defining words. But all primitives in the jeforth are primitives, and they are written in JavaScript. And all the words which you load later are the colon words. And here I just found a very nice way to create new defining words with the create does construct. So we actually have 4 types of words in this system. We have primitive words, which has only 2 fields, the name field and the code field with some execution functions. And we have colon words, which has name field, and the code field just points to nest. This is the inner interpreter. And then we have the parameter field, which has the token list. And constants, variables, and arrays, they all have data in their qf field. And the words you define later by defining words will have all 4 fields. You have name field, you have code field, you have a qf for data, and you have pf for the colon word list, token list. Okay, so the interpreters, we have outer interpreter or text interpreter. This is just the routine we usually call quit, which is begin, parse, evaluate, and again. So it is parse and evaluate doing over and over again. And we have a bunch of inner interpreters. And the inner interpreters are just the routine which sits in the code field. So for colon words, we have the nest. For constants, we have do count. And for variables and arrays, we have a do var. And for all the custom defining word, all the words which defined by custom defining words, they also have the nest in their code field. And all the primitive words, the code field just contains their primitive function. So in the outer interpreter, we have parse, evaluate, and again. So parses out the next idiom in the input stream. And this idiom is given to evaluate. And evaluate can find whether this idiom is a word or a number or none of above. And it can deal with these situations automatically. So actually, I would say nest is the inner interpreter, because all the words were defined in the system after you boot up the system. All the new words are colon words, and colon words all have the nest as its inner interpreter. And this nest is just an infinite loop, which just go through the token list from the beginning to the end. Actually, this is an infinite loop, so it really does not know where it ends. And it is the function exit in the token list, which just set IP to -1, and IP to -1 will cause the nest to exit this infinite loop. So this is the most important inner interpreter, and I would say it's the inner interpreter if we don't want to talk about the other type of words. So let me just restate that the primitive word has a function in its code field, and the colon word have nest in its code field, and it has a token list in its PF field, and constants has its value in the QF field. In the code field, it has do count, and the variables and array has their data in the QF. For variables, the QF has only one item, and for arrays, the QF has an array of many items. But they all share the same inner interpreter do var in its code field. And new words which are defined by defining word will have a nest in its code field. And it has its interpreter in high level in the PF field as a token list. And the data it needed are all stored in the QF field. So constant, here is an example of constant. You have do count in the code field, and you have a number in the QF, okay? And variable has do var in its code field, and in the QF field, it's initialized as a 0, but this value can be changed by fetch and store. So create has the same do var in its code field, and in its QF Q field, it has a list of items, and this you will have to initialize them by yourself. Words defined by defining words would have nest in its code field because its interpreter is written in high level as a code list, as a token list. And if it needs parameters, they are all stored in the QF field. So this is the one thing I want to emphasize, that it is very important to show the stack picture. So this is the part of the output screen. And if I type 1, 2, 3, 4, 5, 6, 7, and the numbers will be dumped out every time the OK is shown. So if you type returns, you will always see all the numbers on the data stack. And I think it should be a standard for all 4 systems. I would hope that Silicon Valley fourth interest group will only recognize 4th implementations, which will dump the stack pictures. Okay, this is a very interesting implementation of all the stack words. You see, we have dupe over to dupe and the swap and to swap to over, all different kinds are implemented with 2 JavaScript function, slice or splice. Okay, all the stack word where the original stack is preserved are implemented with a slice, which is copy out as part of the stack and push it back on the top of the stack. And if the stack needs to be modified, it is implemented with splice. Okay, and here you can see pick and roll. These are the granddaddies of all the stack words are also implemented in slice and splice. So I'm very, very pleased with this implementation because the stack, all the stack words are basically the same using the splice function or slice function of JavaScript. Okay, here we in this implementation, we really don't have the concept of memory. Okay, there's no dictionary. Okay, the dictionary is the collection of all 4 words. So there is no place for you to store your thing except when you define constant, variable, or you do the create. But if you create a new word, you can put as many things into this array as you please. So instead of a fixed and separate memory area, you have to create your own memory area if you do need them. But this system is very flexible so that you can create arrays as well. And arrays are created without allocating any items, and you have to allocate them explicitly. So here, if you create an array called XXX, you have to initialize the items with 1, 2, and 3, and in the system, the XXX will have do while in its code field, and in its Q field, it will have 1, 2, and 3. If you create an array and allocate the number of items in this array, for example, use 6 allot, and you have the YYY with the do while in its code field, and you have 6 zeros in its QF field. And let me see, I think, okay, yeah. So fetch and store. Now, fetches or store variables, constants, and the first element of an array, okay? And for variables, it gives you back the token of this array. And from this token, you can fetch or store. But constant just gives you constant, so you have no way to access it. And the array has many elements, but fetch and store just get the first element. And to access other elements in the array, you use array fetch and array store. And array fetch and array store needs 2 address pointers. One is the token of the array and an index so you can access elements inside this array. And defining words, it needs to access its array in its interpreter, and it uses QF and an index to access however many items you put into that defining word. So here is a word to. To allows you to change the value of a constant, but to has to be used in a colon definition. So in the example, in the haiku example, we use the we set up two loops for the horizontal axis and for the vertical axis, and R fetch, the index is put into X, and R fetch is put into Y. So in the proto, in this code, you can use X and Y to access the image. And is a word in the jeforth 603, it's called a vector. But I think in the fourth 2020 session, I just saw this is. Oh, I said, wow, that's what it should be. So is a word would allow you to change the behavior of a word. So here, I defined Switzerland to paint 1 pixel in the canvas. And so tick Switzerland is proto. So this Switzerland, this word is you will be used in the haiku function, but it's taking the place of proto. So the haiku would do Switzerland instead of doing the Libya flag. Okay, the same as the fourth spire is proto, and then do the haiku. So it is changing. You take a word and then is put into another word to change proto executing Switzerland. So that's it. But the is cannot be used inside a colon definition. It has to be used in the interpreter. So I did a very nice word dump. And this dump, just after you run the system, you compile, define lots of colon word, and you got a huge dictionary. So dump would dump the entire dictionary in a form that can be copied back to the source code file, jeforth, and make all the colon words available at boot time. So this is kind of a turnkey system that I don't know if it is it's useful at this point, but at least it is a way that you can save the compiled dictionary. C allows you to decompile a colon word. And this C is very simple because the token lists are quite simple. And in the token list, all the token, if it has a word, if it is a word, it will just go into that word by the token and print out the name of the word. And there are 6 literal words. And these literal words has literal following this word. So you have to treat the literals differently than a token. So there are only 6 literals in jeforth. Okay, so we have a number literal, which is which uses dolet to put the following number on the stack. And then we have 3 address literals: branch to address. 0 branch also branch to an address if the top of stack is 0. And do next, of course, terminates at for next loop. And if it is a looping, it will jump to the address following do next. And if the index is below 0, it will exit. And so I'm sorry. Besides number literal and address literal, we also have a string literal, with do string and dot string. Dot string implement dot quote. Do string implement string quote. So these will have their string literal following it. And the very interesting thing in JavaScript is that the string literals only occupies 1 token space. So no matter how long it is. So this system is very simple, very beautiful. All the string literals just have the following token as string literal, and just like dolet has a number and the branch has an address after it. So the decompiler is very simple, very straightforward. And this is a comment on do loop. And for next loop needs only 1 primitive word, do next. Okay, so implement all the loops, you only need the 1 primitive word. But do loops require a host of primitive words to support it. So it's very complicated. And this is the reason why I never wanted to put the do loop in the eForth. But lately, when I implement all the Bach organ compositions, all the code were written with F83, and F83 has blocks and it has do loops. So I have to convert all the do loops to for next. But it is very straightforward. You just globally replace loop by next, and globally replace 0 do by 1 minus 4, and all the loops are converted. So of course, there's if you use more sophisticated do loops like plus loop or slash loop, and this doesn't work. So for these special loop commands, you have to go to them individually and try to convert it. But if you just a simple 0 do loop, this method works perfectly. And this is another comment on Brad's block editor. And I also maintain that blocks are not essential to forth. What's essential to forth? Colon is essential to forth. Anything else are not essential. And actually, blocks prevented widespread use of forth because they are not compatible with the other operating system. And the text file are better media for forth programming, for data storage, and information sharing. So I don't like blogs, and I'm sad to see that Brad put the block editors back into the ESP32. You don't need it. Okay, audio context. I don't want, this is just how you implement the voice or the music. So here's my conclusions. JavaScript is very expressive, and Sam Chan coded all jeforth words in JavaScript as primitives, and I think this is a wonderful job. All application words that you loaded afterwards are compiled as colon words. And I'm also very happy to build the create and does, which would define new defining words. And this is made possible because I added the QF field on top of the PF field. And HTML allows jeforth, I should say it's 613 now, and the JavaScript bar to design very friendly user interface for Forth. And the input box and the output box and the text boxes in this interface can accept very large text files, and they can be very useful for us to develop significant programs. And I think that the files are the better interface between human being and the computer, and the blocks are just an artificial way to implement the files. So the jeforth 613, the system code has only 177 lines and 18 kilobytes of text, and it defines 109 words. It is by far the smallest, the simplest, and the prettiest forth I have ever produced. And as Lao Tzu said, for knowledge, learn one thing every day. For wisdom, forget one thing every day. When you have nothing, you can do everything. Have we forgotten things enough? Okay, here is the link to the latest jeforth 613. I will put the link in the chat so you can download it. Thank you very much. Let me just stop sharing. Okay. All right. Any questions?
In your programming, you had a field for basically the name, and then you had something for the function, and then none of those functions actually sort of took arguments. Then you had another variable called, I guess, xt for the data that the function would operate on. In standard JavaScripting practice, JavaScript is basically a hash of key value stores, the key being the name, and the value in your case is always a function. And I'm thinking that rather than breaking this into a thing where everything has a name, you should just use that name as the key to the thing. And therefore your dictionary is just an object, and everything in your dictionary is a function. And then if you have a special property to the function, modern JavaScripting practices, most people, because everything's an object in JavaScript, these special properties for your certain words would just be a property of the function. And I don't know, Brad can probably answer this, but a lot of the funny things people do with ES6 and the fancy stuff for syntax makes it harder when you get to actually implementing things down at the hardware level. So there may be a reason why you did things the way you did. But I think if you used some of the ways people use JavaScript today, you could actually simplify your code. But I'll let Brad weigh in on that.
No, I don't think so. I think the way the forth works, okay, forth, this is an implementation of forth. Java is just happen to be the virtual machine underneath it. Forth requires, okay, a name field, a code field, and for the conventional forth, a parameter field. But here, I think just the one parameter field is not enough. What we do in forth is we use the parameter field to store a token list if it is a colon word. And we use the parameter field to store data when they are defined as a constant, variable, or arrays. But here, I think we have to separate these two different data types in two different fields. So the PF field will only contain token list. And if this data, put them in the Q field, okay? So if you separate these two fields, separate these two different data into two different fields, forth becomes very simple when you want to define new defining words, okay?
Okay.
I will say also, if the suggestion of using the dictionary, a dictionary directly to reference item or an object, that the downside would be that you would lose the chain of the same word redefined. So you would it would be faster for lookup, but it would also have the downside that you wouldn't have the sort of chain of them sitting there in the stack, which would violate some properties of the system. I would like to say on the block thing, I thoroughly agree with the sentiment that blocks are not intrinsic to forth, but I think that blocks are an interesting idea in their own right. Their conflation with forth, I agree, has been problematic in terms of its adoption. It's a lovely idea if you're on a system and you're too lazy to write. If you have to write your own text editor from scratch and you have to bring up your own file system from scratch, I think it's a lovely concept. The trouble is, of course, that these ESP32 boards we're already relying on there being a file system there, so it's rather silly in one sense to have a block editor. And I will say in my defense, I only did it because I started down the road of trying to write a text editor and thought, boy, this is hard. Let me start with a block editor. And so
yes. Yeah, if you don't have a file, if you cannot handle text files, block is the very reasonable alternative. But if you already have the mechanism to handle text files, there's no need of the blocks.
Well, I will say the block. It's not just the lack of the file system. It's the need to write a text editor. If you want a text editor that runs on the device, right. Now you've got it's a harder problem to write a text editor for general code or general text than as opposed to blocks. That's a sort of a.
That's right. Okay. Thank you.
Not to say I'm not going to give it a try at some point. This is sort of it's on my list. Then we can ditch the block editor.
Okay. Okay. Where's
okay? I tried to find all my unmutes all at once. Thank you so much, Ting. have thought a little bit about what honorifics to use when I speak of people like Brad or Ting or Dave Jaffe. You can fill in your mind whatever language you use when you're describing such people, but the word that comes to mind is teacher. And whether you use sensei or rabbi or any of the other honorifics that go with that. Dave objects to professor because it has specific context. So pick one that you don't object to and fill that in your mind with the most weight you can give it. So thank you, Ting, for your presentation. And thank you, the rest of you presenters. Unless anybody else has something specific that they'd care to talk to us about for 20 minutes.
I have maybe one more question now that I've succeeded to double unmute.
Go.
Dr. Ting, probably a simple question. What would show up on the stack after I call a variable? Is it the index in the dictionary of the variable of the word?
Yes, it's the token. If you execute a variable, you get a token, okay? And from that token, you can use fetch and store, okay? And for a constant, you just get the number. You don't get the token. But if you tick a variable, you get a token, okay? And from that token, you can use fetch and store to change a variable. Okay, so it's very it's very flexible in that once you get a token, you can do anything with that token. But you don't have a dictionary in the conventional for system that you can freely fetch and store. You can only fetch and store to variables, constant or array.
All right. I was thinking that it would be nice to talk about programming challenges. If anybody has one that they'd like to recommend to Bill, now might be a good chance. Bill is here, so we can't talk about it behind his back, darn. But it might be something that we can talk about and amplify and discuss amongst ourselves. All right, so nobody stuck their noses in. Bill, unmuted. Okay.
I just say more new challenges are totally welcome. My email address is bill@billragsdale.cc or bill@billragsdale.com, and send them in. Wait for them to come tumbling in. bill@billragsdale.com.
Okay. I was thinking about interfaces, and the most common way to talk to stuff these days is USB. It's kind of a broad problem to talk about in a programming challenge, though. If we maybe limit it to a USB thermometer, and maybe I'll pick one out that's inexpensive. And the challenge would be to read a USB thermometer from a Forth program running under Windows. Let me tell you the madness to my method. or the method to my madness, I guess it is. Just kidding. I was thinking that it would be nice to write a fourth program that would measure the temperature of a cup of coffee to reasonable accuracy. It would not have to be accurate. It would just have to be precise, if you know the meaning of those two words in the measurement, the metrology sense. The reason I want to do this is if I can get this into a table or an Excel spreadsheet or a open office spreadsheet, is that I can measure a cup of coffee over time and say, okay, it's cooling this fast and it starts at temperature X and it reaches temperature Y. There's an old puzzle. Okay, so you have a intern that you send for coffee and you tell them, okay, it has to arrive at my desk at the highest possible temperature available. And then the
Leave meeting.
person goes to the
Goodbye.
bye, Bill.
Goodbye. I gotta go. Gotta go.
The person goes to the Starbucks and gets the coffee and is asked, okay, do you want the cream on the side or added? And it turns out counterintuitively that if you add the cream, it reduces the temperature of the coffee and arrives at the desk at a higher temperature than if you had it, in a separate container. There's a thing with Newton's cooling law. I won't bore you, but it strikes me that this is a great science experiment for kids in grade school. If they can measure the temperature with their computer and they can have a fourth program that spits the numbers out over time, they can prove to themselves that if it starts at a lower temperature, it'll arrive at a higher temperature. Go figure.
Yeah, that's good. That's good.
And if we get all these kids with these three things on their desk, they have the thermometer, they have the first piece of lab equipment that they'll ever come in contact with. They have, maybe a yardstick or something might be, maybe bludgeon them with the yardstick. I don't know. They'll have a computer and they'll have a fourth program. And what's the first thing you do when you have a fourth program? I don't know about you. I change it. So we'll get them fiddling around with this piece of source code that they'll have at their fingertips, and my measurements come in twice as fast as your measurements, or my measurements fit in a smaller space, or something. Optimizing for their own criteria that they will supply, and maybe, just maybe, we'll suck them into this. Now, I need some input, and you're welcome to either speak up now or maybe talk to me later. How you do all this stuff. If I were doing it, I might think about maybe talking to an Arduino with a thermometer, because the Arduinos might be an easier way to get sort of real world stuff into the hands of these guys. It may be that yeah, I see Dudley says copy in chat is disabled. I didn't know that was a thing. Maybe it's always disabled. Is it something that Dave Jaffe could turn on and allow us to copy from chat?
No, this is
this is a issue in Zoom. We are saving the chat for later, but you can't copy text from a chat typically on a PC. Sometimes you can do that on a Mac. So the thing to do is if somebody puts a link on there, click on it and it will open it up in your browser, and then copy and paste the link from your browser into, a text file or something.
Dave is so smart. I I used zeal, ignorance, and brute force. I just took a screenshot and said I'd worry about it later, but I said it to myself. So anyway, all these thoughts running around in my mind, I think I've tried to communicate them pretty well about this temperature taking experiment. The advantage in having a thermometer that's hooked up to your Arduino is that at that point, not only do you have a thermometer, but you have an Arduino, which has an A to D converter, as far as I know, and you can plug into your Arduino this super zoomy James Bowman Dazzler video card. And speaking of the Dazzler video card, how many of you have bought it? Show of hands. Okay. Cool thing. And I recommend it to you. And it may be one of the only products, aside things you buy from Mitch Bradley, that actually has Forth in it. I think that there's some water sprinkler controllers from Lego that might have Forth in them. We'd have to ask maybe Leon when he joins us at some future date. Leon is scheduled for March. I'm looking forward to hearing him. I guess will be a video that we will show that Leon has made since he is unable to join us in real time. So anybody else, any further questions, any other exciting challenges that you'd like to? Ting has his hand up.
Yeah, I think the Arduino is a great idea, okay? But I think the better idea is that Arduino on the ESP32 would just accomplish what you want if you have a temperature sensor that can be hooked onto the A to D pin of ESP32. Okay.
Yep.
But the regular Arduino with the 328, that chip also has 6 A to D channels. And I think if you just figure out one way to hook a temperature sensor to one of these A to D pins, then you can measure temperatures. And then you hook a light sensor, LED, to one of these pins, and you can measure light. Okay. So I think all these things are interesting experiments we can do, but temperature sensor, I know several chips that's very good in temperature sensing, but they have bell wires sticking out. So you need.
Ooh, icky.
So if you stick it in your coffee, you have to worry about collusion and all the other things.
HPD pin, what's that?
And you're going to have to decide whether you want A to D, which is difficult with temperature sensors because they move a lot. They have a lot of noise on them. Or a I2C one, which is the more common way to get temperature into embedded systems. You mentioned USB. USB on Windows is an exceedingly complex stack.
Yeah, no kidding.
That's why you want to go to Arduino.
Well, correct. If you go to Arduino, then you do have the capability of I2C or A to D. There's trade-offs with both, but I prefer the I2C. But now you've got to have a Arduino chip that has an I2C controller on it, which many do, but they don't all. And then
I've been known to bit bang it.
Mm-hmm.
Yeah, well, you can always bit bang I2C if you want another challenge.
Yeah, well, the ESP32 has a built-in I2C interface.
Yeah, I agree with you. The ESP32 is a wonderful chip. All sorts of different ways that you can get one.
I see Pat has unmuted and is raising his hand and stuff. Can we
Sure.
hold that thought, Dennis?
I went ahead and bought the Udemonic little scamp computer that was demonstrated in December. And after, I'm still trying to figure out some ways to have it talk properly by a terminal. But one of the things I've discovered is it comes with a temperature sensor on board. And I mean, it's not, I move it over my heater and it properly gets me about where I've got the heater set, and I take it away and bring it to the ambient temperature of the room. It's actually doing a reasonable job. It's not very precise, but it's kind of a fun, and I wasn't expecting that to be there. And it has a huge number of features that I have not yet been able to plumb because I'm bringing myself back up to speed after many years of not doing much with it. But it was $19 with about $19 of shipping from Australia. But anyway, fun thing.
Many embedded systems do have temperature sensors on them because it is a critical factor in many embedded systems. You've got to know temperature. If you've got a battery, you've got to know temperature because it changes the battery. So yes, that's also, if you specify which board they have to buy, that's the other problem with ESP32 is the number of possible packages is infinite. There are so many different packages for ESP32. Mm-hmm. It's all over the place. And so you have a pinout problem there. And yeah. But
I was just going to say that jokingly, you could ask Lady Ada. She's done this several different ways, probably. If you don't know Lady Ada, you should look at adafruit.com.
Yeah. Okay.
Yeah, I have another suggestion, which you can use the Arduino interface to work with, but using the blue pills are the dirt cheapest way to do anything. The processor cost on the little board cost around $2 each. They can be used through the Arduino. I don't use them that way, but you could. They're as far as temperature sensors, you can get one of the little clock chips, and they come with a temperature sensor in them. Also, you get those on the little. I guess they're connected to SPI. I think they're connected to SPI, but you can run those pretty easily. I've used those myself. They're really easy to talk to. It's either, I don't know what bus it uses, whether it's SPI or not, but the blue pill can support all of those different things. But like I said, as a $2 processor, it's probably the cheapest way to go. It's comes on the board, has a USB interface. The only disadvantage with the blue pill is that you like a blank Arduino setup, right? You have to use their downloader, which is why I don't use it. but you know, and that has to be done through a serial port. But that's, you know, if you have like a classroom or something like that, all you need is one USB to serial, right? To program the whole pile of them, right? With loaders. Once the loader's in them, they can run on the Arduino interface. And it isn't much to, they have quite a bit of libraries and stuff in there available for them. So they're like I said, just about the cheapest way to get any of these little microprocessors. The blue pills are not, they don't have an enormous amount of memory. They don't have an enormous amount of stuff, but I run forth on them all the time. So, you know, it's pretty straightforward. I'm using a eForth that I got from Dr. Ting a long time ago, and that seems to work fine. I can talk to SPI. I can talk to. I use the SPI usually to talk to the little SD cards, which I store stuff on. Usually what I do is I take the SD card, and I use blocks still myself and on that. But what I do is I create a file on the Windows machine that's going to be big enough to hold all of the screens I expect to put in it. And then I have those blocks available. I can still read them on the PC, or I can add stuff to them or whatever I want on the PC, or I can access them from the blue pill. But all I use the file system for that's on there is just to locate the data, and then I can write the data directly to the SD card without having to know anything specific about the file system used. Just the location of the data is all you need. But that's like I said, the blue pills are really cheap. They're you can, you know, add other little boards to them. You can add the like I said, they have the little clock devices that you can get. And the only problem with that, again, it still has the problem of dunking it. No matter what you do, you have the problem of dunking it in the coffee.
You're right.
And
if somebody would export forth to the Pi Pico,
yeah,
you expand your
It's
membership
been done.
and lower the average age of
Yeah.
this group.
Yeah, it has been done. I just saw.
Has it really been done?
Yeah, I just saw last few days.
No kidding.
There was one for the Pico.
I'll go for that.
Yeah, I was going to suggest that too. That may be a more useful way, because then you've got an OS.
Yes.
Yeah.
And if you've got a Raspberry Pi 400, you've got everything.
Yeah, you've got a computer, a supercomputer at this stage.
I bought a couple of these Seed
Oh, I love
Studios
Seed.
Arduino boards. Everything is wired together right there. Plug it in USB into a PC, probably Mac, and it's got temperature, humidity. What's on there? Accelerometer, air pressure, light, sound,
Yeah.
pots, button, LED buzzer, OLED display. It's a pretty cool thing to get kids playing with right out of the box.
Yep. Yes. Seed. I love Seed. Seed does real good. They are out of China, and they have a lot of intellectual property, and they're doing AI on boards. They've got a lot of stuff going.
How much do they cost? Where do you get them?
I don't
seed.
remember. I believe I did it through Kickstarter or one of the organization. Just Google SEEED.
Yep.
The Pi Pico costs as much as $4.
Right. This is a little bit more expensive, I believe,
Seed Studio.
but it
There is.
wasn't very much. Are you looking it up, Dennis?
Yeah, I've got it here in a moment. Let me get something to copy and there we go. Where are you guys? There you are. Someplace over here. Type a message. There's Seed Studio. Yeah. Yeah, I've got one of their AI boards. And
Look
yeah.
for the Grove Beginner Kit.
Grove Starter Kit.
Yeah, one reason why I was attracted to ESP is the Wi-Fi. Okay, now we don't
Yes,
have to have a physical connection, and you see, I think we should be having having a program on the PC. Which looks around on the Wi-Fi and look around for all the instruments that can talk Wi-Fi. So I think if we want a coffee temperature measurement thing, we could have it. In the, for example, ESP32, and have the sensor will just send out Wi-Fi signals telling us what the temperature is all the time. And if you have a computer which can read those Wi-Fi signals, then you have a temperature sensor that might be able. You might be able to put in your coffee cup and send out the measurement on the Wi-Fi.
Peter sent me a message. You want to share your screen with me or with everybody, Peter?
I want to share the screen, but then, may I?
You have to ask Dave.
I am asking Dave, but where is the
Dave has to make.
I got it. I'm doing it right now. That's I gotta find your name in the list here. Hold on.
While he's doing that, I was thinking, can everybody hear me?
May I share my screen, Kevin?
Yes, he's working on it, Peter. Hang on just a minute. But
Okay.
while he's doing that,
Go ahead. Go ahead.
Can you hear me?
Yes.
Okay. So I was thinking of proposing a challenge that is just draw a block diagram and tell me what kind of device you plan to use and what your interface is and what kind of forth would talk to it. Is that a reasonable finite programming challenge for 1 month's work?
You'll get a lot of variation, but yes, that would be the way to start.
Well, if it seems like it's a worthwhile thing for folks to do, and it points us in the direction of the goal, and it's finite enough for 1 month, it might be a reasonable thing to do it that way.
And it
I
would
like
be
a lot of
useful.
variation.
It would
ahead,
be
Dennis.
very useful to have a hardware platform that we can talk forth on, that we can talk about on. It's a problem we've had throughout the years of having something that we can work with. Now, Don's doing some of that with the ESP, and Brad are doing that, and Ting is doing that with the ESP32. And that is a place we've got already. If we've got other things to go to, but yeah.
The little scamp computer, I mean, that I got from Australia, that the guy demonstrated here, is easy to get running, and it has all kinds of input output capabilities, and it's good learning. Good learning. I'm reteaching myself a lot as I go.
You're done with Don's computer using it as a thermometer.
So let's come up with a platform.
Yeah. Sorry, I was mute.
Okay,
Now,
are
you
you
should be
prepared
able
to share your screen now?
Yes, yes.
There you go.
Here,
Great.
the solution.
That's an ESP32. I
Yes, this
recognize
is a temp sensor DHT22, the ESP,
Yep.
and the solution. This is what Brad is doing, ESP32 from Dr. Ting, and it works perfect. It's
Yeah,
very nice.
and that's what Don is doing. This is what Brad is working on. Is he's working with Don and Ting, and they're all working on this platform. They've been working on it for a while, and it looks like a decent platform to me. I haven't bought one yet, but
one of the advantages of this platform is that you can buy it everywhere.
yes, yes, the ESP32 is everywhere right now.
Well, I would say that for the purpose of a challenge, Kevin, I think the fewer constraints you place on it, the more interesting the things you'll get out of it. But I think there's, certainly the ESP32 has been something where it's been fun to have a little consensus on devices to tinker with. But I think in terms of these challenges that we've been doing, I've been fascinated every time we do one where folks come back with surprising things. And so in some ways, setting a general goal and then seeing what you get is half the fun. So. Although I'm sitting here wondering now if anyone sells a food safe Bluetooth thermometer, because then then you can talk to it from the ESP32 but not have to tackle the problem of making the thing food safe.
That's true, because you've also got Bluetooth on there. That's what I love about that chip, is the Wi-Fi. That's why it's become so popular.
I think one of the things you have to tell the kids in the class is you don't need to use coffee. And oh, by the way, you can't put whatever it is you do this with in your mouth. Do not drink it, please. Because then, even if you stick a dirty thermometer in your stuff, it gets you out of a lot of world of hurt. It reminds me of the Penn and Teller magic book, where they included a prank, this Tyvek sugar packet, and for some reason the publisher decided he needed to put something toxic in this Tyvek sugar packet, and I think Teller, Penn Jillette went to the original guy who invented this prank and said, well, they want to do this. What do you think about that? And the guy said, I don't know. It seems kind of stupid to me. And he asked, well, what did you put in it? And the guy said, well, sugar, of course.
So even if you open it with your pocket knife, it always gives me a hoot to see kids around who show up for a meeting without a pen, or who are working their way through a laboratory or other setting without a pocket knife. You know, it just seems to be amazing that they get out the door with their pants on these days.
Yes, those kids.
Yeah, I had to turn my meeting on so you could see me shaking my fist. You kids, get off my lawn.
We are all stroking our beards.
Yes, we have a few of them in this group.
Mine is virtual. All right. One of the many things I learned from Robert Heinlein is that a motion to adjourn is always in order. It takes precedence. It is not debated. All right. Without recourse to Robert's Rules of Order, it probably has other features that are interesting, but let's